Hello friends, today I am going to tell you about the air circuit breaker. What is the air circuit breaker and how we are using this air circuit breaker, especially for relay setting. How to set the trip setting value in circuit breaker. Okay, this is the circuit breaker. Okay, air circuit breaker. The make is ABB. Okay, this is the model Emax E1. This breaker model is because the ABB have so many models. This one little the construction wise a little different. So this make is ABB and model is Emax E1. Okay, this is the circuit breaker. This is nameplate detail. The rated amps is 1600 amps and voltage 690 volt. This is the short circuit and the battery breaker category is B. Okay, and operating frequency is 50 to 60 hertz. This is for coil voltage detail. For under voltage coil is 220 to 240 volt under voltage. This one 50 to 60 hertz. The coil tripping shunt coil voltage is 24 to 30 volt DC for DC voltage. Okay, so this is for off push button, on push button, spring charge indication. This one the breaker condition for on off status. If the spring is discharged, here the display is showing for spring is discharged condition. Now the spring is already charged condition, that's why the spring is now in charging mode. This is for manual spring charge handle. Suppose the spring is in discharged condition, we should for auto, here already have the auto spring charge motor. If something have problem in auto spring charge motor, we should charge the spring manually. So through this handle for up and down we can charge our spring. Now I am going to tell you about the importance of trip setting value. Okay, this is the relay setting coordination. So here have the settings. This one for current limit setting, this one time setting, because all trippings follow the time current and time curve. Okay, current and time curve only follow that all trip setting. So first one is overload, this one short circuit, instantaneous, ground. So how they are setting this value, this is I am going to tell you. You look here inside, there are small knobs, right? So how we are change the setting means this position of these small knobs up and down, depending upon this up and down position we set the value. So this is I am going to show you. So you look here, this is the position of this small knobs. We follow this position of knobs, we same which value we need to set, same model we put this one up and down. Okay, so here you look, all three knobs are downside. Okay, it means the IR value means continuous current rated amps for if more than this setting value, the load arms is taken, the breaker is automatically tripped. This is the overload. So this one 0.4. If two knob is downside, one knob is upper side, it means the set value is 0.5. This first knob is lower position and the second knob is upper position, third knob is lower position, it means the set value is 0.6. So how the overload current we will set here means, you look here, this is the IR value. Okay, IR value, this is, so first for here the position is 1 2 3 knob is available. First two knob is in upper position and last knob is lower position. So we can look here where this value is available. Two knob is upper position, you look here 1, it means the IR value setting is 1. Okay, so because same position here, 2 nab is upper position, 1 nab is lower position. It means they will set the value is 1. Okay, plus here both nabs are in down position, so down position means is 0. It means 1 plus 0 equal to 0. So this value into ln means nominal current. Nominal current where? Nominal current is here 1600 amps. Okay, so 1 into 1600 amps, if you multiply the answer is coming 1600 amps. So what is our overload setting means? If the breaker load is exceeded more than 1600 amps, the breaker will trip. So how many seconds it will take to trip? Okay, so this is the tripping time, because most of the breakers are follow the time current curve. Okay, so this is the time. So here the time is 2 nab is downside, 1 nab is upside. Okay, where this position here 2 nab is downside, 1 nab is upside. Okay, here second one you look, 2 nab is lower position, 1 nab is upper position. It means they setting the time delay is 12 seconds. If suppose the breaker is continuously taking the load of 1600 amps up to 12 seconds, so after 12 seconds the breaker is automatically trip. Okay, as per the overload setting. This one short circuit. Short circuit means mostly they are set the short circuit from 1 to 10 times of nominal current. Okay, short circuit is 1 to 10 times of nominal current. So how many your load before you are setting, you should calculate the short circuit current of depending upon your load. So how they are setting here, how much they are setting for nominal short circuit current means, you see here there are available 4 nab. Okay, first 2 nab is lower position, second 2 nab is upper position. Okay, so where this same position where here available, first 2 is upper position and the second 2 is lower position. Okay, here 3, right? Okay, 2, you see first 2 nab is lower position and second 2 nab is upper position. It means the value is 2. Okay, so 2 means the nominal current is 1600 amps. So 2 into ln means nominal current. So 2 into 1600 means 3200 amps near coming. Okay, so when the amps is going to 3000, short circuit current is going to reach for 3200 amps, the breaker is automatically trip. The tripping time is 2 nab is downside and 2 nab is upside. So where this position means you calculate the first 3 nab, first 2 nab is in downside, third nab is in upside, so same 0.2 second. If the load current, short circuit current is reached 3200 amps above, this breaker is stripped within 0.2 second. Okay, this one instantaneous means there is no any time delay. When the fault current exceeded the presetting value, the breaker is automatically tripping without any time delay. This is the instantaneous. Mostly they are set the current value from 2 times to 15 times of the nominal current. Okay, now they are setting 3 nab is downside. So here 3 nab is downside, where the position. Okay, this one 8, you look here 8. So it means the instantaneous 8 means because here first nab is upper position, last 3 nab is lower position. So the set point is 8. So 8 into nominal current. So 8 into 1600 amps, because the nominal current is 1600 amps. So 8 into 1600 amps, how much coming? So that value, the short circuit current is reached for this value instantaneously, the breaker is stripped without any time delay. This one ground fault. Ground fault means Here there are three positions. First knob is in a lower position, second knob is upper position, third knob is lower position. The values were coming 0.3. Okay, here see 0.3. So 0.3 into nominal current 1600 amps. So 0.3 into 1600 means around 300 amps coming. So when the ground fault current reached above the 300 amps, the breaker is tripping. The ground fault, there have time delay. Time delay, what is the time delay for this ground fault? First knob is downside, second two knob is upper position. It means one down, one up, 0.2 seconds. So when the ground fault current reached above the 300 amps, the breaker is tripped automatically within 0.2 seconds. Here how frequency, there are two kind of frequency. 50 hertz also you can operate this breaker, and 60 hertz also you can operate this breaker. Okay, so this is the for this one for position of breaker. This one connected position, test isolated, disconnected. It means you look here, one black knob is there. Suppose the breaker is in service position, it means connected position. That's why the black knob is near parallel to the connected. If the breaker is in, you put in test mode, it means you put in rack out. So rack out means if, when this knob is coming test position, the knob is coming test position, it means the breaker is in test isolated. Okay, if I want completely disconnected from this breaker to rack out outside, so I need to bring this knob into disconnected position. So how I bring this knob into here? So this is the rack out handle. I have one handle for rack out handle. Before I put this handle, this knob I pull downside. So when I pull this knob downside, the hole is open. After that I insert my rack out rod in this hole. After I rotate the anti-clockwise. So when you rotate anti-clockwise, the connected position into the knob is coming to test isolated. After continuously you rotate, the knob is coming to disconnected position. Suppose you want to rack out this breaker, means same procedure. Before that you pull in downside to this knob. After the hole is open, after you install the rack out handle, before you rotate the anti-clockwise, now you need to rotate the clockwise direction. When you clockwise direction, the breaker will go to the bus bar. So this knob is again the opposite direction from disconnected test isolated connected. This is the way of ACB operation and presetting trip setting value of protection, overload, short circuit, instantaneous, ground fault. Thank you.